The Avro Arrow, a supersonic dream grounded the Avro Arrow. Even decades after its dramatic demise, the name evokes a potent mix of pride, regret, and a persistent what-if in the Canadian consciousness. More than just an aircraft, the Arrow was a symbol of audacious Canadian ambition, a technological marvel that pushed the boundaries of aviation, and a poignant tale of a national dream abruptly shattered. Its story is one of cutting-edge engineering meeting complex geopolitical realities, ultimately leading to one of the most controversial decisions in Canadian history. The genesis of the Avro Arrow is firmly rooted in the turbulent post-World War II era, specifically the intensifying Cold War. By the early 1950s, the threat of Soviet long-range nuclear bombers overflying the Arctic to strike North America was a very real and terrifying prospect. Canada, situated directly in this aerial pathway, found itself on the front lines. The Royal Canadian Air Force, RCAF, needed a high-performance interceptor, an aircraft capable of rapidly scrambling, climbing to extreme altitudes, and engaging supersonic threats. At the time, Canada's primary interceptor, the Avro CF-100 Canuck, was a subsonic, straight-winged aircraft, already becoming obsolete in the face of emerging jet technology. Avro Aircraft Limited, a subsidiary of the British Hawker Siddeley Group, had a strong track record, having designed and produced the Canuck. Tasked with developing a successor, Avro Canada embarked on what would become Project FS-22, aiming for an aircraft that would not just meet current threats, but anticipate future ones. The initial design parameters were incredibly demanding. The aircraft needed to achieve Mach 1.5 at 50,000 feet, possess excellent maneuverability, and feature an internal weapons bay to carry the new generation of guided missiles. Crucially, it needed to operate efficiently from relatively short runways, a practical consideration for Canada's northern airfields. What emerged from Avro's design offices was nothing short of revolutionary. The Avro Arrow was a large, twin-engine, delta-winged interceptor, a design choice that offered numerous advantages for high-speed flight. The delta wing provided significant lift at high angles of attack, excellent stability at supersonic speeds, and substantial internal volume for fuel and weapons. Its sleek, area-ruled fuselage minimized drag, a critical factor for achieving and sustaining supersonic flight. Key design features and innovations. Delta wing, a 60-degree sweep contributed to its impressive high-speed characteristics and stability. Internal weapons bay. Unlike many contemporary interceptors which carried missiles externally, the Arrow featured a retractable internal bay. This reduced drag significantly and protected the missiles from icing and aerodynamic forces at high speeds. It was designed to carry up to 8 air-to-air missiles, including initial plans for the Canadian Velvet Glove and Astra, and later the American Hughes AIM-4 Falcon and the advanced Sparrow II. Power plants, the early prototypes, Mk1, were powered by 2 afterburning Pratt and Whitney J75 turbojet engines, each producing approximately 24,500 lbf of thrust with afterburner. However, the ultimate intention for the production Mk2 was to use the Canadian-designed Orenda Iroquois engine. The Iroquois was a technological marvel in itself, a powerful, lightweight and efficient engine designed to deliver over 20,000 lbf dry thrust and 28,000 lbf with afterburner, among the most powerful engines in its class globally. Fly-by-wire, early form. While not fully digital, the Arrow incorporated an advanced control system that included hydraulic power-assisted controls and an early form of fly-by-wire in its stability augmentation system, which utilized electronic signals to help stabilize the aircraft, especially at high speeds and altitudes. Integrated avionics. It was designed to carry the sophisticated Hughes MG2 fire control system, which could track and engage multiple targets, guiding the aircraft and its missiles to intercept. Avro Arrow specifications, Mk1 prototype, Mk2 planned. On March 25, 1958, Avro Chief Test Pilot Janusz Zurakowski took the first Arrow, RL-201, into the sky. The initial flights were remarkably successful, exhibiting excellent handling characteristics and easily achieving supersonic speeds. The 5 completed Mark I prototypes quickly racked up impressive performance figures, with RL-203 reaching Mach 1.96 at 50,000 feet, limited only by the J-75 engine's thrust and not the airframe's capabilities. Test pilots praised its responsiveness and stability. The Arrow was on track to meet and likely exceed its design goals, particularly with the more powerful Iroquois engines planned for the Mark II. However, a storm was brewing, not in the skies, but in the political and economic arena. The project's costs were spiraling. Initial estimates of $160 million had ballooned to over $400 million, and projected unit costs for production Arrows were becoming exorbitant for a nation of Canada's size. Simultaneously, the nature of the Cold War threat was evolving. The focus was shifting from manned bombers to intercontinental ballistic missiles, ICBMs. This led to questions about the continued relevance of a high-performance manned interceptor in the age of missiles. The Diefenbaker government, elected in 1957 on a platform of fiscal conservatism, was under immense pressure. There was also significant American influence, pushing for Canada to adopt the less expensive ground-to-air Beaumark missile system as part of a joint North American Air Defense (NORAD) strategy, rather than maintaining a costly independent manned interceptor program. The debate was fierce. National technological sovereignty versus financial prudence and integration with a continental defense strategy. On February 20, 1959, Prime Minister John Diefenbaker rose in the House of Commons and announced the immediate cancellation of the Avro Arrow and its associated Orenda Iroquois engine program. The decision sent shockwaves through the country and the aerospace industry. Within weeks, on the direct orders of the government, all existing Arrows, along with the production tooling, blueprints, and even the partially completed NK-2 prototypes, were summarily destroyed. This act, often referred to as Black Friday, sparked outrage and disbelief, fueling conspiracy theories that endure to this day. Over 14,000 highly skilled Avro employees were laid off. Many of Canada's brightest engineers, designers, and scientists, disillusioned by the decision, emigrated south to the United States, contributing significantly to the burgeoning American space program, NASA, and other advanced aviation projects. This brain drain represented a profound loss of intellectual capital for Canada. The Avro Arrow remains a powerful symbol in Canada. It represents both the pinnacle of Canadian industrial and technological achievement and a painful reminder of lost potential. Critics argue that the cancellation was a short-sighted blunder that crippled Canada's aerospace industry for decades. Proponents contend it was an economically necessary decision given the changing strategic landscape and the prohibitive costs. Regardless of one's stance, the Arrow's specifications and historical context paint a picture of an aircraft that was truly ahead of its time. It was a testament to Canadian ingenuity, a supersonic dream that soared briefly before being abruptly grounded, leaving behind a legacy of what could have been that continues to fascinate and inspire. The surviving nose section and various artifacts serve as poignant relics of a golden age of Canadian aviation, a fleeting moment when Canada was at the forefront of the technological frontier.